Okay, welcome to the next section. Here we're going to solve some differential equations. Now, a differential equation sounds like something that's really scary, but in reality, a differential equation is just a derivative. It's just an equation that has a derivative in it. That's literally what a differential equation is. It's an equation that has a derivative in it. So here we have y prime equals 3x squared. That's the same thing as dy dx equals 3x squared. And what the question is asking us to do is something that we're used to in math, which is find the solution to this equation. That's all it's asking, find the solution. It just so happens that this variable, this term, represents a slope. So we're looking for all equations of the form y equals something that will satisfy both sides of this equation. That's all we're doing. And one way to do this is to just do a process called separation of variables. And so what I'm going to do is I'm going to rewrite the differentials so that it looks like this. dy equals 3x squared dx. Okay, that's called separation of variables. Now I know it looks like I just multiplied the dx over, and I know that's kind of what this looks like. That's not exactly what we're doing here, so you shouldn't think of it that way. It's more like I'm just separating the dy dx, because what I'm going to do now is I'm going to take the integral of both sides. And when I do, I get y equals x cubed plus c. Because remember here we want to find all solutions. We want to find the general, this is called the general solution. This is the answer, by the way. We want to find the general solution such that it satisfies this equation. And sure enough, if you put x cubed plus c in for y, take the derivative of it, you get 3x squared equals 3x squared. So that's all we're doing. Y equals x cubed plus c is all of the general solutions, all of the different equations that we can plug in for this equation for y, so that both sides of the equal sign are equal to each other. And so that's how you solve a differential equation. So let's do the next one. Here we have ds dt equals blah, blah, blah. This time they're giving us some initial conditions, so that means we'll be able to ditch the plus c and find one equation who will solve this equation and satisfy s equals 200 and t equals 0. So again, rewrite it like this. And separate our variables. So we have ds equals 22t squared plus 7t minus 3 dt. And then we just take the integral of both sides. So we get s equals, this will be 22t cubed over 3 plus 7t squared over 2 minus 3t plus c. Okay, so I did that kind of quickly. It's because I've done these so many times. Hopefully by now you're at the end of the class. Hopefully you can do these pretty quickly. Just take the derivatives of each of these to get these right here. Now, we have an initial condition when t equals 0, s is equal to 200. And so that means that if I put 200 here and 0 in for everything else, I can find my initial condition. So it doesn't have to be 200 and 0. If it wasn't, we would just put in different values here. They make it 0 to make our lives a little easier, because all three of those terms go to 0, so we get that c is equal to 200. As I said, they don't have to be nice like that, they just did that to make it nice for us. You could put in a value for t and s and then calculate what c actually is. But this enables us to narrow down our equation to just one equation. And that is the answer. And so this is the one equation that if you plug in s into here, you get the derivative of it. You get that it equals 22t squared plus 7t minus 3, and it also satisfies the condition that this equation does, that when s equals 200, t is equal to 0. So this is the answer to the differential equation. There's a whole class dedicated to studying these types of equations. It's actually called differential equations. You'll discover that some of them actually don't have answers that we can easily detect, or they have way too many variables, and so we have to solve them in other methods like numerical methods. So if this interests you, I encourage you to continue your math education. All right, we will stop this video right here, and I'll do some more examples in the next video.